Hello viewers, welcome back to our YouTube channel, and today we want to continue with our series of quantitative techniques. And in the previous video we had looked at the first three measures of central tendency, that is the arithmetic mean or mean, the median, and then the mode. We looked at all of them for both group T data and ungroup T data set. And what I want us to look at in this video for today is what you call the weighted mean, the geometric mean, and then harmonic mean, if time allows us. Now, of course, as I told you, there are others like the combined mean. We shall maybe just give a formula about it if at all time allows. But all these three are additional items that we look at when we are dealing with the measure of central tendency or measure of location, and they all help us to determine that middle value. Now, of course, today is 22nd of July 2026, and our focus is to complete the measure of central tendency, and I want us to start with the weighted mean. Now, we said that the first three, the mean, the median, and then the mode, are the most preferred measures of central tendency, and these three, they are the ones which we shall focus on when we are dealing with measure of dispersion and also dealing with the skewness. But there are situations or there are aspects, there are certain situations where the mean, or what you call the arithmetic mean, may not be able to reflect the true picture, of the distribution. However much it will give us a rough idea of the average value of a certain kind of distribution. But there are situations, and we are going to look at probably some few examples just to help us understand the concept, that there are situations where the mean or the arithmetic mean will not be able to give you the true population parameter. It will not be able to give you the true picture of what the distribution is like. Of course, one of the examples that we can look at maybe if we are dealing with the maybe expenditures on, let's say, basic necessities. If we are looking at expenditures on basic necessities, if you're looking at the basic necessities that we have maybe utilized in a particular year, you can't use the mean to give you a good picture of the basic necessities that you have used in a given financial year or in a given particular year. The reason is very simple. You may look at the things that, let's maybe first highlight the basic necessities, the basic needs or the basic necessities. These are the things that you can't do without. Maybe we can have food, we can have housing, we can have maybe clothing, and maybe you can say water or drinking. Let's say drinking water. Now, if you try to look at these items, if I'm looking at how much I've spent on such and such items, it will be unrealistic for me to use the mean to try to get the average expenditure that I have incurred on the different basic necessities. Reason is because these items, I'm going to consume them in different capacities or in different volumes. If I say that on my clothing, I've spent, let's say, 150. Maybe on housing, I've spent 200. And maybe clothing, I've spent maybe, let's say, 50. Then maybe for, let's say, drinking, I've spent, let me say 100,000. Just getting the average of these values by adding the 150 plus the 200 plus the 50,000 plus the 500, and then I divide by 4 because they are 4. The items are 4. This is 1, 2, 3, and 4. So if I add this and this and this and this, then I divide by 4, whatever I'll get, it will not give me the right picture of how much I actually spent, because you are going to find that some of these line items I've spent maybe huge quantities on, let's say, the food, and less on these other items. So when there are those items that are going to be, let's say, they are not uniform, because sometimes you may find that the mean of the data set, in which not all the values are going to be equally represented. In other words, there is no way you are going to say that here maybe I utilized maybe 8 kgs, let's say, of rice. And you'll find that maybe for water, maybe you just used maybe 3 liters. So you'll find that you're going to find yourself having some weights. And these items, number of items, they are the ones that we call the weights. So if you find that in that given data set, the mean of that data cannot be just computed roughly by just adding the number of items, then you divide by their total numbers, and then you end up with that rough figure. Because if the values are not equally distributed, then it is going to cause a problem. Because if at all I had all these line item and maybe I spent, let's say the unit of measurement, they were the same, everything was the same, maybe everything was in maybe kilograms. Let me say if it was uniform and I've spent 8 kg for each of those line item, then it will be very fair for me to just add up these expenditures and then I divide by their number because they are uniformly distributed or they are equally represented. So if we find ourselves that maybe the unit of measurements are different and in terms of the quantities, they are also different, they are not the same, it means for such and such a scenario, if we just get just the mean, it will not give us the true picture, because sometimes the data set may contain entries that have a greater effect on the mean than other items, because you may find that within the food, maybe we consumed maybe 50 kgs. So the moment that we find these weightings or these weights are going to be a little bit different, they are not evenly represented, then it's better for us to use the weighted mean. And for us to find the mean of this data set or for the weighted mean, we consider the case findings. In other words, we look at the different item that we are looking at. If you are analyzing a scenario, maybe relating on the consumption, the items consumed, the big question that we have to ask ourselves is that how many of these units did we consume, so that we can attach the weighting, because they may tell you that we've spent, the prices was such and such for the different items that we have consumed, maybe as household items. But the big question we have to ask ourselves, how many of those items did we actually consume? Because by knowing these items, you are going to find that some items you'll find yourself you have utilized more of those items than other items. And the implication is that they are going to affect our overall average. The very quick or straightforward maybe example that we can look at, if maybe we are a company and maybe we are dealing in transport services, maybe you have different buses. We have different buses. Let's assume that we have 3 buses, and these 3 buses, each of these bus takes a different route. You can have maybe one that goes to the north. Let me just use regions. One goes to the north, and then the one goes to the west. Let's say the West Nile, and then maybe the other one goes to the east, the eastern. Now, if we have 3 buses, and each of these consume, let's assume all of them, they consume diesel from different petrol stations or from different gas stations. You'll find that each of these buses, since they are taking different routes, it means they are going to consume their diesel from different locations. So you may find maybe this is petrol station, let's say this is A, Maybe this is B and this is C. Now, what you are going to find is that you'll find that these gas stations, they price their products differently. You'll find that a bus, maybe bus A, which was going to the north, consumed, because even the distance is going to be a little bit different. If the distance is longer, it means that bus is going to consume more power or more diesel for maybe going to the north and then coming back. Now, what is going to happen is that if you just base on one aspect, that the price, because these gas stations, they are not in the same location, so they are charging different prices. You may find that maybe gas station A charges, let's say, 5,000 Ugandan shillings per liter. Then you find that gas station B maybe charges 4,500, and maybe gas station C charges 4,800. Now, it wouldn't be a problem if at all these buses were to consume the same amount of, or the same liters for all their locations. It wouldn't be a problem. So if we have these buses and maybe they are consuming, let's assume they consume maybe 50 liters to and fro, 50 liters, and it is uniform, then we will not have any problem, because we have all these. Even if the prices are different, we can still determine the average price per liter of diesel that these buses are consuming. It wouldn't have any problem with us. Meaning the average that we shall get from this will be a realistic average. But now, given the fact that these buses are taking different routes, it means they are going to consume different liters of diesel. We can assume that maybe bus 1 is going to consume, let's say, maybe 20 liters. The other consumes 30, then the other consumes maybe 15 liters. Now you will see that it will be hard for us to just go on and we just get the average price. We add the 5,000 plus the 4,500 plus then the 4,800, and then we divide by 3. That will give us the mean. So that mean will be wrong. The reason as why it will be a correct mean, but it will not give us the true picture of what the average consumption of these buses is, because we know that each of these buses consumes different liters. So for you to solve such a situation or such a scenario, you need to use what we call the weighted mean. It will be the weighted mean that will give you the correct or the true picture, meaning that these liters are now going to be the weights. The other example that we can also look at to try and internalize this, of course we are looking at the applicability. If maybe you're looking at the grading points, if you are a university student, of course these, they call them cutoff points. Cutoff points. when these universities are computing their cutoff points, they always have what we call the essential subjects, and then the relevant. Or most of the times, this essential always carries a higher, points, because for this one they always multiply by 3, and this one they multiply by 2, and then the other one, others, they multiply by 1. So if you are going to choose maybe a combination, maybe you have done MEG, you have done mathematics, economics, and geography at A level. If you are going to apply for, let's say you are going to apply for accounting and finance at a certain university, they will tell you that the essential is maybe economics or math. So if math and economics are the essential 2 subjects, most courses have, especially business courses, they always have that economics as an essential. So you'll find that mathematics and economics, if you have gotten an A in mathematics and maybe a B in economics, and maybe you have gotten a D in geography, what they are going to do is that this A will represent 6 times 3, because it's an essential, that gives you 18. Then they also get economics, you got a B, that's 5 times 3, that will give you 15. Then the D, it has 3 times 1, that gives you 3. When they add all these values, then they also add the other one for O level. They add something small from there. I think it is always, 0.1. They always multiply, I think, by 0.1. 0.1, depending on those, whether you've gotten D1. There are those small percentages, but when you compute, it roughly can't exceed 3.5 from that. So if you add here 3.5, you'll find yourself having this. But the reason as to why they are multiplying these, what they are multiplying here is the weighting. Those are the weights, because they can't just add up the scores that you got. Reason is because some of the subjects carry higher points, and those points can affect the average. So in such a situation, we can't say, since you've gotten an A plus a B in economics, then we just add 6 plus 5, then plus 3, we divide by 3. That will not make any sense. Of course, there is the other computer and GP, which have not computed, because those are not, they are always considering 2 principal passes. And most cases, those courses, that you find that it has maybe 1 or 2 that are essential. So in such situations, we don't use the mean, we use the weighted average. So that's what I wanted to clarify, that in some situations we may end up having to use the weighted mean, because the mean does not reflect the true picture of the distribution. So if that is the case, now to know the steps that are involved. Steps that are involved in the steps. the steps involved in getting our weighted mean. Of course, if you want to get to find the weighted mean, we always get those values, maybe they are x values, we get those variables, variable x, and then we multiply each of the values, by its corresponding weight, and then we divide the total, we divide by the total, or the sum of the weights, So let's write it as a formula. We look at it as a formula. Of course, we get the product of the weights and the each of the individual values. Then when we get the product, we sum the product of those individual values, and then we divide by the total number of weights. So we've said the formula for the weighted mean is equal to the summation of the weights times the x values over the summation W for the weights, where x is the individual values, and then the W represents the weights, the individual weights. So for this one, for the weight from weight n, all the individual values, then n, maybe this n will represent the number of values. In other words, we just get the summation of all the product. We get the summation of all the products of the values, and then their weights, then we divide by the total number of weights. So the weighted mean is an average computed by giving different weights to individual values. So if the weights are all equal, then the weighted mean will be the same as the mean. But the moment we have the weighted mean having different weights, then it means we have to compute the weighted mean will be different from the mean, because these weights carry, or they have a different effect on they have a differing effect on the average of the distribution. So the data set with a high weights contribute more to the weighted mean than the data set with lower weights. That's the implication. So the weights, of course, in this situation, we always take them as frequencies. But these frequencies can't be negatives. You can't say I bought, if let's say we are looking at expenses on basic needs, you can't say I spent maybe negative 10 kgs. Maybe we used negative 10 kgs. They can't be negatives. So the frequencies can't be negatives, or the weights can't be negatives. Some of them may have zeros, but we can't have, these are some of the properties, we can't have all the weights being zeros. Because the moment you have all the weights being zero, it means you are going to get a number and then you divide by 0, of which doesn't exist, or it will be leading us to infinity. So they can, some of the weights can be 0, but not all of them. That's the implication. So one key thing for you to note is that each of the items in the distribution affects the mean differently. So if an individual, let's say the individual does not, let's say, maybe travel a lot, you'll find that the price increase in transport will not be the same, or will not have the same impact as the other price increasing. So maybe let's look at just a small illustration to just put in context what we have seen, the theoretical aspects. Example, let's assume that this is weighted mean, and let's have maybe a diagram. We have items, we have price, present prices, and these prices are in thousands. The first item, we have food, we have drink, we have housing, have transport, then finally we have entertainment. Entertainment is our last. So they are in thousands. This one is 150, this is 130, this is 200, this is 120, this is 180. Of course, this information represents the expenditures on the different items. And now they gave us the weights. The weights for each of the items. This one is 8. This one is 6. This one is 5. This one is 2. And lastly 3. And the required is for us to calculate the weighted mean. We need to calculate the weighted mean. So we have been given the different items that we've spent in a given period of time, and they have also given us the weights or the quantities that we have bought. They have not told us they are in maybe in kgs or what. They have just given us the weights. So what we need to do is to make sure that we get the weighted mean by just multiplying the price times the weight for food, then we add the product for drink, which is 130 times 6. We add the housing, which is 200 times 5. We add the transport, 120 times 2. Then final entertainment, 180 times 3. We add the product of those different items, then we divide by the total weights. Total weights, we are going to add 8 plus 6 plus 5 plus 2 plus 3. That will be the total weight, or the total weights. So if you want, you can put it in a table. You can have these as our values. Solution. Can have these as our x values. Then we have the weights. We just call it W. This is 150. They are in thousands. Here they are in thousands, so that you don't forget. So this is 130. This is 200. This is 120. This is 180. Then you bring here the weights. Because here we are going to get, they have given us the weight. Here is 8, 6, 5, 2, and 3. So we are going now to get the weighted value, or the product. In other words, this one is going to be the W times X values. That's what we are getting there. So this one is going to be 150 times 8. That is going to give us, this is giving us 1,200. We do the same for this, 130 times 6. 130 times 6. That giving us 780. Then we do the rest. 200 times 5. 120 times 2. And then 180 times 3. This is 540. This is 240. This is 1,000. So once you add all these values, this is summation W times X, which is equivalent to 3,760. And if you add, you get the summation W here. Summation W here is equivalent 24. So the weighted mean weighted mean is actually the summation Wx over summation W. So it will be the 3,760 divided by 24, and that will give you 156.667. Of course, this one you multiply by 1,000, and that will give you this one times 1,000, because they gave us these values in thousands, and that will give you 156,667,000 shillings. This is our mean. So that is the weighted mean. And of course, now I want us to look at the geometric mean, because the other harmonic mean is just a reciprocal. It is the reciprocal of the harmonic mean. Is very easy because it is just the reciprocal of the mean, of the arithmetic mean. So let's look at the geometric mean. So we want to look at the geometric mean. Geometric mean. Can use GM as the abbreviation. Geometric mean. Now, we said that the arithmetic mean is the sum of the values in a distribution divided by their numbers. Now, when it comes to geometric mean, this is the nth log. This is the nth log or nth logarithm of the sum of the logarithms of the values divided by their numbers. Now this one is a little bit different from what we have been doing. The geometric mean looks at the nth log. The nth log, we write it as if it is having an inverse. The log, then with an inverse, as if it is an inverse of a log. But it is very easy for you to compute. But what I want us to understand is the applicability of the geometric mean. Of course, the geometric mean is mostly used to show what we call percentage changes. It is always, or most of the times, it is used to show what we call percentage changes. That is the main purpose. It is used to show percentage changes in the series of positive numbers. So as long as we have positive numbers, we need to see the percentage change. In other words, it's going to be a positive change. We always want to look at the increment, because if there is a positive, it means something is increasing. So it is going to be very applicable in areas of economics and of course in areas of business because of the interest in the changes in certain variables. For instance, these changes may be in terms of the changes in sales, changes in the gross domestic product or the GDP, the economic growth, the inflation rates, the interest rates, the population growth. So it is in those areas where we try to look at the average. We get the geometric mean, but this geometric mean is basically giving us the percentage changes in the different positive numbers from the different perspectives. And of course, we have seen that we can use it particularly in areas, in the areas that are interesting us to find maybe the average change, let's say in the cost of living. Maybe you want to find the percentage increase in the inflation. If you want to find out the different rates of depreciation of the given assets. So in some of those areas, that's where we apply the geometric mean, as long as we want to look at the change, but this change is in the positive numbers, or we want to look at the percentage increase, we always use the geometric mean. Of course, this definition may look a little bit longer, but you can also define the geometric mean as the nth root of the product of the n items in a series, and this n is a capital N, meaning it is the values, the values we are talking about, they are population values. Remember, we said in statistics, when you use capital N, we mean number of items in the population. When you use a small n, those are number of items in a sample. So we get the nth root of the product of the n items in a series. So if the numbers are 100, then we get the product. We get the product and then we take the square root of we get that if they are 10, then it's going to be the 10th root of the product of those numbers, those 100 numbers that we have got. But most of the times this, we don't use it. Reason, what if now we have 1,000 numbers? Are you going to multiply all those numbers? That's why we take the logarithms. We get the log, because this log is going to help us get smaller values. Now what if I'm multiplying, what if the values are multiplying there in thousands? Will I manage? We try to introduce in the logarithm to help us reduce these values, or we reduce these values in what we call small values that we can deal with. Remember, the bottom line of this, of having this data to be, is for us to actually get to an understanding, to simplify data so that everyone can understand. Because it would be very easy for us to multiply even if there were 1,000 numbers. Mathematically we can do that, but it will take a lot of time. That's why we are introducing in different items or different methods that are helping us to break down the hard data set into and is a form that can be understood by all people. But if they ask the definition wise, of course, you can just say it is the nth root of the product of the n numbers or n items in the data set. But if you see that the question they have given to you, maybe the data set is too small, you can just multiply the data. If maybe there are 5 figures, you can multiply those 5 figures and then you get the fifth, because if there are 5 numbers, then it means you will get the fifth root of that product. The answer you'll get will be the same. But most of the times we don't use it because the data set that they may give to us may be a little bit huge, and we may find that we have to use the logarithms to help us reduce those data sets into smaller denominations that we can deal with. So as I said, the geometric mean can be GM, geometric mean can be the nth root of the individual values x1 times x2 times x3 up to xn, where n is the number of values, number of individual values, or can say geometric mean GM. Geometric mean can be you get 1 over n. N is the number. Then you sum up the logarithms. The log of x1 plus log of x2 plus up to log xn, and that will give you the geometric mean. So either way, depending on the data set, it is very important that you look at the data set that has been given to you. This one may look easier, but you have to understand the data that has been given to you in the question. So let's look at maybe a small simulation to help us put in context what we have seen. Of course, this will be the log. This one is, it shows log. This one indicates log of the geometric mean, because we said it is the ant log, and we said the ant log, we can write it like this, then of that item, because these logs that we are summing up, let me write it here. If you don't write it that way, because that one can disturb you. So we said we can write it as the geometric mean can be the ant log. Can use words ant log, then in bracket to put the summation of log x x, this is for all the individual values over n. I'm using the n, I'm using capital N to represent the population, but if they bring a sample, it's the same thing. So the ant log, or the other person can write it as log, then he puts that -1 to mean ant log of summation log x over n. I just took this 1 over n in there, like from the other formula that we have just seen. So either way, so whichever way you choose to go by, you'll be good to go. So I want us to look at just a small simulation, then we look at the harmonic mean. Let's look at the simulation example. Let's say that the harvests of maize, in 10 farms in Chiboga district. Chiboga district is given, or are given in the table below. Full stop. Calculate the geometric mean. So in the table we have different values. I'm just going to use one table for the solution and then for the question. I'm just going to put the x values. We have the x values. The first value, so the first x value is 7.5. Next one is 13. This is 18.5. This is 20.5. This is 5.2. This is 23, 24, 25, then 26 and 28. Let me first write all the values. And of course here we are going to get the log of x. For the different values. So what you are going to do, you place log of on your calculator, then you place 7.5. This will give you 0.8751. Then you place log 13, that will give you 1.1139. You get log 18.5, that will give you 1.2679. The reason why we use the log is that it gives you the smallest values that you can deal with. So then finally you get the log of 26, which is 1.415, and then maybe the last one, log 28, that gives you 1.4476. This 72. Those ones you maintain maybe at least 3 decimal places at least. So now you add up, you get the summation log x. You add up all these logs that you have gotten. We've seen that the total summation log x is equivalent to 12.2860. You make sure you compute all those values to get the summation log x. Now once you have gotten the summation log x, now we are going to get the ant log. How do you get the ant log? You place your shift on the calculator, shift, then you first press shift key, then you press log. That will open, of course it will open up that ant log feature. Then you put in brackets, because we are going to get 12.286 divided by n. Our n, these numbers were 10. You divide by 10. Or you can first get the summation log x divided by n. Of course, if you divide this by 10, this decimal point will move here. It will be 1.22860. Then you get the ant log of this. You get shift, you press shift key, then you press the log, and then you type 1.22860. It will give you 16.9277 something. Of course, you go ahead to round off the values, and that's how we get the geometric mean. It's not a hard thing. If you are okay with multiplying, you will see that we have 10 digits. So it means you will multiply 7.5 times 13 times 18.5 times 20.5 times 5.2 times 23 times 24 times 25 times 26 times 28. The answer you get, now it will be, our n is 10. It will be the 10th root of that product that you have gotten. So here we get our geometric mean, and we said our geometric mean will be the ant log of 1.2268860, and this will give you a 16.9277 and other values. But if you choose to multiply these other values, if you want to get it in the other aspect, you'll get, it will be the 10th root of the product. You get 7.5 times 13 times 18.5 times 20.5 times 5.2 times 23 up to times 28. The whole answer you get, now you will get the 10th root What I want us to know is how do we press on that one on a calculator. I'm just going to use a small number so that we can know how to place that on a calculator of getting the 10th root. Of course, this one you'll just press the shift key, shift. Actually, you first press, if let's say we are getting the 10th root of 4. You first press 10, shift. Let me write it again. 10, shift. Then you go to that symbol. It has a square root like that. It's called the power. It's not even. When you press, it will get for you that symbol. There is a symbol that looks like that. Press 10, shift. Then you press the power. It's a power button. It's actually the power button that has, it is the power button like that, depending on the calculator you're using, is the one that will give you the shift will be to locate this value, this symbol, because the key has this. When you press it, when you press shift will be picking this other symbol. Then you put a 4 and you find that the answer you will get is 1.14869 depending on the decimal places. But for these numbers, since we are going to have most of these numbers in very big, the decimals are going to be many, so you maintain at least 3 decimal places. But if you can, you make 4, because in the exam we always look at trying to manage time and all that. So that's the geometric mean. But one thing I want you to understand is that how do we differentiate the means that we have computed for, you try this same number and you first compute the mean, you add these x values and then you divide by 10. You see the value that you have got, then you compute the geometric mean. You will always see that the geometric mean will be of a much more representative of the distribution than the mean, because you look at you look at the mean that you have gotten. Now for this case, we've gotten geometric mean as 16.9. Since geometric mean is 16.9, the mean will be higher than 16. You'll find maybe the mean is around, let's say, 20 or 25 or 23, depending on the computation. Of course, when you compute these values, you will see. But this one, the geometric mean will be more accurate, because you can see that in this data set, we have very many values that are below 16. We have 17.5, 13, we have 5.2, those are some of the values, but you see all those values are somehow close. But even we have values that are above 16.9. We have the 18.5, the 20.5, 24, 20. You are seeing now the mean, the geometric mean is not all that much bigger than these values. It shows as if it is within the range. So you can try to get the computation, and you will see that the geometric mean will always be lower than the mean, because this one has some weights. So let's look at the harmonic mean. For the harmonic mean, I'm just going to give you the formula, then harmonic mean and the combined mean, these ones I'm just going to give you the formula, because the computations, they are the same as what we did previously. For arithmetic mean, it's only, what is changing is only few things which I can explain, then you'll be able to go through them. So geometric mean, no, harmonic mean. What you need to understand from the harmonic mean is that the harmonic mean is just the reciprocal of the arithmetic mean. In other words, the harmonic mean, I'm just going to call it HM, harmonic mean is just the n over summation 1 over x. So this n, where n is the number of values, and then x represents the values, the individual values. So it is just the reciprocal of the arithmetic mean. For arithmetic mean or the mean, we always get the summation 1 over x. So just the summation x values over n. Because if you try to get the reciprocal of this, it will be this one. This n can be small, or it can be big, but let's maintain the n to be big with the assumption that we are dealing with a population. So we just interchange what was at the top, let it be at the bottom. Now, of course, this is for ungrouped data. For the grouped data, we have frequency that is going to be involved. If we have frequency, we just put in the frequency. We just insert the frequency here, and that's it. So for the grouped data, we just get the harmonic mean will be n over summation f into 1 over x. That's it. This you can make it a small n or a capital N. So this one, it is the same. You first compute this item, you get 1 over x. If you are setting up the table, maybe just to show you how we can set up the table, we set up the table like this. We get the values. Of course, these are the x values. Then we get the frequency. This one will also be given to us. Then we get 1 over x. Then we get f into 1 over x. And then the total we get here will be the total that we are going to use. the summation f into 1 over f, 1 over x. You can try to put in values, maybe 1, 2, 3, 3, let's say maybe 1, 3, 5, 7, 9, maybe 11. Then the frequency you can put in maybe 2, 4, 6, 8, 10, maybe 12, the last one. Then of course 1, we get 1 over 1, it will be 1. This one, 1 over x. Our x is 1 over 1, it gives you 1. Then 1 over 2, this is 3. 1 over 3, it will give you 0.3333 recurring. And this one will be 0.2. This one will be 0.1429. This one will be 0.1111. And lastly, we can have it is 1 over 11, which gives you 0.0909. Then you multiply 2 times 1, it's a 2. 4 times 0.33 will give you 1.3332. This will be 6 times 0.2, it will be 1.2. This is 1.1432. Then this one is 1.1111, and lastly we have 1.0908. When you add up those values, this one will get 7.8782 maybe. Then we also add up the summation. We add up the frequency, get the summation f. The total frequency is 42. Then you get the harmonic mean. The harmonic mean will be the 42 over 7.8782, and this will give you a 5.3312 as the harmonic mean. So it is all about just interchanging those values. It is just the formula that changes, but definition wise, a harmonic mean is computed as the reciprocal of the mean. So we get the mean of the reciprocal of the numbers or the values in the distribution. Maybe just to conclude on the combined mean. Of course, for combined mean, it is very easy. Just the formula looks at two means when they have given you more than one average. If you have different data set, but you can compute average of each of those values. It is the same thing, but maybe to highlight for a combined mean. So for the combined mean, you have to have data set, different data set that you can get mean. In other words, you get arithmetic means for the different items, as long as they are more than one, the variables, they can give you height, then maybe they give you scores, then you get mean of the heights, then the mean of the scores. Those are the two arithmetic means for the two variables. Then you just combine, or what you call you get a composite mean of the two variables that have been given to you. Said we look at the combined mean. So for the combined mean, still let me just represent it with x bar. It will be n1 x1 plus n2 x2 over n1 plus n2, where of course n is the number of let me write where first of all the x1 x2 represents the mean, shows the mean. Then this n1 n2 up to nn up to the nth number, these ones they represent the size. So the examiner will always give you the n1, the n2, and then they give you the, if they don't, most of the time they will not give you the x1, because the x1 is the mean. This is mean 1, mean 2. Those ones you compute. So it depends on the different n values they have given to you. So the size, you may find that they have given to you 3 variables, maybe sex. They can give you sex, then they give you male and female. Here of course you have 2 variables. You compute the male and then the female. Then you'll be able to get the overall mean for the different data set that has been given to you. So that's what I wanted to have or to share today as far as the measures of central tendencies are concerned. This one I combined it because it is more of the simplest things that we encounter, because I told you the basic ones, they were the mean, mode, and then the median. But even these ones are also examined, though they are very easy. So what we are going to look at, of course, this concludes the measures of central tendency, and what we are going to look at in the next video will be about the measure of dispersion. Measure of dispersion. They don't call it dispersion, they call it spread. In other words, here is where we are going to look at things to do with variances, things to do with maybe the coefficients, the covariance, the coefficients. Of course, most of the times we look at also the standard deviation, we look at maybe the range. Of course, we shall also look at the interquartile ranges. and then the percentile, the decile, and other stuff. And of course, that will be our chapter 7. Chapter 7. So don't forget, those that want to join our classes, we have recorded classes with no ads. We have uploaded them and you can access they are on a different platform that can only be accessed after we have granted you access. We charge 200,000, and that 200,000 gives you access, a full year access or full 12 months access to all CPA classes. So just WhatsApp us on the number that we have put on the screen. You'll be able to get in touch with us and be direct when you text, so that we can be able to add you and be able to have these pre-recorded classes that are giving you access to recorded classes and then the revision classes for each of these course units, CPA course units, for all the levels, with no ads. You just watch them as if you are attending the normal classes, because they are class recorded lectures. So that's all that I wanted us to get as far as that announcement is concerned. Thank you.